The way to do this is a rejection region. This is not my favorite, but this is actually an example. This is a callback to one of the other ones that we did. Two competing headache medicines give fast-acting relief. An experiment was performed to compare the mean lengths for, okay, there are 12 randomly. Okay, we've talked about this. And this was a T one. So this is the second one we did because we have S there. The researchers at both distributions are approximately normal. S use a 5% level of significance. So that's very important. So what we've got to do on this one, you won't have any of these on your homework, by the way. Level of significance 0.05, but there's no difference. So what you have to do is you have to establish what's my rejection region going to be. So it's a T distribution. Now, for the T, for the degrees of freedom, we're going to use the smallest n-1, which is not completely accurate, but it's accurate for doing it by hand. So the smallest n-1, 12 minus 1 is 11, 12 minus 1 is 11. So we're going to have a degrees of freedom of 11. Okay? And what you have to do is we're going to 5%, and they're trying to see if there's a difference between the two. So it's a two-tailed test. These two areas have to add up to 5% or 0.05. So how much are each one worth? They're each worth 0.025. So I've got to find the T at this high end here. So how do I find the T at the high end? I could use something called inverse T, second bars, inverse T. Now, what's the area? Well, when I'm at this high end, I'm wanting to know, when it says area, I want to know what's at that point below. So what's at that point below? Well, it'd be 1 minus 0.025, so it'd be 0.975. My degrees of freedom is 11. So my T is approximately 2.201. And so I'm also going to have a negative T, negative 2.201. So that's my rejection region. So what I have to do is I have to calculate what the T statistic is. So how do I do that? I can go, well, actually we've already done this, but I can go to stat test, two sample T test, stats, X bar 1. So I'm going to calculate the T statistic from my thing. I'm going to see if it jumps into the rejection region. So X bar 2 is 18.9, S2 7.5, 12, and then this is A not equal to, no for pooled, and I'm just going to calculate here. I just need the T. My T is 0.875. So then what I'm going to do is I'm going to plot the T statistic that I calculated on this curve. So 0.875 would be right here. So the question is, does this value dip into the rejection region? If it dips in the rejection region, then you will reject HO. But if it doesn't, then you fail to reject HO. This does not go in the rejection region. So therefore, since 0.875 is greater than, or less than 2.201, we fail to reject because it does not dip into the rejection region, fail to reject HO, which means it's not statistically significant, and it means we have insufficient evidence. So this is not my favorite. Some teachers teach it this way, and I'm not going to write all the summary out, but basically we find the rejection region, which is less than negative 2.201 and greater than 2.201, and we use our value, find our T value, and see if it dips in the rejection region. If it's in there, if it's in the shaded area, you reject. If it's not in the shaded area, you fail to reject.